So we've talked a bit about wind's influence on the globe, different types of wind. Now we can talk about wind's influence on the oceans or large bodies of water. Basically, as wind travels along a water surface, it pushes it to the right of the direction of the wind. I'm not going to get into the physics of why that happens. Just know that it's always going to happen 90 degrees to the right of the wind force. So in this case, you've got a wind moving north to south, so the wind moves out, or the water moves out away from this coast, and it creates an upwelling impact because, again, that surface water needs to be replaced. It's not just going to move away, so it's pulling water from below called upwelling. That water is much colder, and that's why the ocean along the west coast of the United States tends to be colder in summer than you'd kind of normally expect for its location and the time of year. That's why places like San Francisco tend to be much cooler, not just because they've got water close by, but because the water is specifically colder because of this upwelling impact. And this has a major influence on what we're going to talk about next, which is El Niño Southern Oscillation, which is a major atmosphere-ocean interaction that impacts the rest of the world that happens in the Pacific. So what's happening here, this is a normal or non-El Niño conditions. You've got, again, the strong trade winds. You've got the normal impact of winds moving up or down or towards the equator, really, and forcing water away from North America and South America, creating that upwelling, cool water being in this region. And then you've got on the opposite side of the Pacific, on the western side of the Pacific in Indonesia and Australia, you've got kind of the opposite impact. It's forcing water sort of down. You've got warmer water pooling here, and that creates a really good situation for storms. You get a lot of storm activity here in normal years, and that creates a lot of water for Indonesia, Australia, which makes sense given their climates being, or tending towards being tropical rainforest, particularly Indonesia for that. And that creates this circulation of rising air moving over, creating storms, spreading out, and then sinking over the dry region. When you get to an El Niño year, this system breaks down. These strong trade winds are no longer really present. Everything kind of gets a countercurrent going, and the storms move with it. So again, you no longer have that upwelling, bringing cold water to the surface. So this area warms up quite a bit. You get a lot more storm activity in the eastern Pacific. The ocean levels kind of go up because they're no longer being pushed away from the coast. And the storms that are normally over Indonesia have moved away. So you get a lot more dry in this region, and you get sinking air. And you've reversed that circulation. This happens about every 4 to 7 years. And this has major implications for the rest of the world. You can see kind of a look at sea surface temperatures, what it would look like during an El Niño year. Like I said, the Western Pacific, a little bit cooler than average, a little cooler than normal, but not particularly. But there is a lot more warmth here in the Eastern Pacific. Again, this warm tongue really emphasizes that. And so with this area being about normal and this area being much warmer, this results in a lot more storm activity over this red area. And this has global impacts, like I said. So during El Niño winter, that warm tongue that I just showed results in warm and wet conditions over sort of the eastern Pacific and even into the central Pacific. And that spreads out. You get warm and or wet and cool conditions over the southern United States. You get warm conditions here along Canada and Alaska, and similarly here. And again, it spreads to areas of South America as well. Basically, it propagates out from there. Whereas the lack of storms results in dry and really warm, because again, you're getting rid of cloud cover as well, over Indonesia and Australia, and just over the Indian Ocean as well, and it spreads out from there as well. And slightly different things happen during the summer, but again, still similar in global impact. And there are things that happen in Antarctica. I'm not going to get into what exactly those are, but that's what I did my master's on, which is always fun to talk about. And then you've got La Nina, which is kind of the opposite. So again, whereas El Nino was the breakdown of those trade winds, La Nina is the amplification of them. It's much stronger. So again, instead of this being warmer, it's a lot cooler, because again, you're getting a lot more upwelling, a lot stronger push out to the central Pacific, and it results in much stronger concentration of warm water over here, and it ends up being much wetter in Indonesia and Australia, just over this region. And this similarly impacts things. So you get propagates out as well. So whereas the storms are now here, it ends up because of how they propagate out, it ends up being cool in different regions, wetter in different regions, and this has, again, global impacts.